All right. Let's get going here. So it's Sunday morning. We do labs on Sundays. So I'm gonna run through some labs, and we will get as far as we can go. We're doing Kubernetes, so we'll do my Kubernetes labs this time. Jeez. We'll do my Kubernetes labs this time. Maybe we'll go hop over and do some of the other ones. We'll take notes on them as we go. We like to do that because we like to remember things, so it's valuable to do that. Which distro of Kubernetes? Well, I guess I'll tell you. Let's see. It's a strange question, but I'll answer it. Uh, 1.30. I know what you meant, Joe Father. I know what you meant. There you go. 2004. The version that's on Killercoda. Fisherman, I'm always on my laptop. I haven't ever streamed from a normal system. I've been on a laptop my entire time. Okay. So, sound should be, hold on. Let me go make sure my sound is right. Give me a second. Oh yeah, that's definitely not going off my, that should be better, right? Fisherman? Yeah, it's now back on my, yeah, I went, you're right. So my microphone mixer always says it's the Yeti, but it was set inside of there to be the, the laptop one. So yeah, I'm back off the Yeti. Good. All right. Yeah, good looking out. All right, so we're gonna do labs, and this isn't the one I would have started with, but that's fine. We'll go ahead and start with this one. So we'll say lab 1 is blue-green deployments. All right, so we'll do some blue-green deployments inside of Kubernetes, and we'll see how everything kind of works out here. So, how does one start? Inspect the deployments practice YAML file in your home directory. So I have something in your home directory here. And this is a file, so we can run it and see what it creates. But while we're doing this, we can open this image here in a new tab, and we can see very plainly what we're doing in this lab, right? We're going to build some stuff inside of Kubernetes, some what's called a deployment. We will make a deployment, and that deployment will make some pods. Those pods will have labels on them, and then those labels will be selected by a web service, so a service. We'll call it web service, and it'll point to the labeled Nginx blue at first. Then we'll go point it over to the Nginx green, and this is the exact type of model that we have when we do what's called a blue-green deployment. We flip from one side to another, right? And Chilling Spree over on YouTube, yeah, I appreciate that. It's a good catch by Fisherman. My microphone was definitely set to the wrong one, so it should be better. Well, it sounds like that's what you guys all listened to yesterday then, because this thing was set that way yesterday. So, all right, so we're gonna set this up then. So we're coming in here. We're gonna clear this up, and we are gonna go to our solution. We can just more our root deployments practice.yaml, and there, if I remember correctly, but we're gonna look at it. There are 4 config maps that we're going to make, and then there are 4 different deployments that we're going to make. Yeah, we're just starting right now. Yep. This is blue-green deployments inside of Kubernetes. I kind of make you run through some things, so if you guys have not done Kubernetes before, there's some things that I kind of assume you know. This is not what I would call like the absolute beginner stuff. But in my little deployments practice file, I have every time you see 3 dashes, it denotes the start of a new YAML file. Or in the case of when you're feeding something into Kubernetes, it's the start of a new API call. So this is your first API call. Technically, fully disciplined, I should have had 3 dashes at the top of this. So I should have these 3 dashes at the top of this file. It's not required, but it is good practice. And what I mean by that is, like, it's not required here. Kubernetes can chew it up. But I've seen tools like Werewolf where you can pull a configuration out of Werewolf and it won't put the 3 dashes at the top. But then when you go and you put and you go to import that same file that you just exported back in, it'll say, nah, bro, I don't think that's YAML, until you put 3 dashes at the top of the file that you just pulled out of it. It's ridiculous. All right. Anyways, so this is what's called a config map. Config maps can store secrets. Now, there's a secrets tool, so that's a little better. But what we can also do with the config map that some people like to do for web pages is we can store inside of a config map a file. So in this case, index.html is defined by everything found right here. And this is the simplest web page you will ever find. It tells you it's an HTML page. It opens up the HTML tag and closes it. It's got the head and the close of the head. It's got some style and some body information in there. And then down here in the body, it just says this is a light blue background. That's the whole thing. That's the whole page. So that's our blue page. Then starting here, we've got our green page. So we come down. Oops, I did not mean to do whatever that was. I was going to say, we're only in more. What the hell's going on here? All right. Green is the same thing. It's doing whatever the hell it's doing. And then we come down here, and I have 2 that are called yellow. And one is the original yellow, and it's got Canary version 1 on it. And the other one is the second yellow, and it's got Canary version 2 on it. You'll notice that the page for that is light blue. And the reason I did that is because the yellow was just so ugly, I decided to get rid of it. So, all right. So we've got 4 config maps, 4 definitions of web pages that are simple web pages that are just stuffed into Kubernetes. So now Kubernetes can reference those whenever we want, and we can pull those inside of deployments. So here's a deployment right here. This will be the full definition of a deployment right here. And there's 4 deployments here. The first one calls Nginx deployment blue. That's its name. It's got some labels. It'll be called Nginx blue. And then down in its container spec, it calls the Nginx container. And what it does then is it does this, let's call it a clever little thing, where it gives a volume, it attaches a volume, and the volume is just reading that config map. And then the volume mount, where that volume actually gets put inside of Nginx, is user share Nginx HTML, and then the name of the file which gets dropped in there is index.html. So if you ever go to the Docker image for Nginx, you'll find that the path user share Nginx HTML index.html is where you put something that you want to be the web page of that Nginx, right? It thinks I'm saying Nginx. It's Nginx. There you go. That's better. So, that being said, we have in this deployment. Let's look at what it does then. So we say kubectl get pods. There's nothing there. Kubectl get deployments. There's nothing there. Kubectl get CM, which are config maps. There's one, which is a certificate, which we don't care too much about. But then if we ls and we do a kubectl create -f on that deployments that we just looked at, what we would expect to see is 4 created config maps, which are the definitions of index.html files, and we would expect to see 4 deployments. Now within those deployments, so if we do kubectl get CM, we'll see those. If we do kubectl get pods, get deployments, we'll see those deployments. Now those deployments also created replica sets, and those replica sets are down here, and replica sets are really what control the number of pods underneath. Remember, I told you guys there's always a desired. That's how many it wants to have. There's how many it does have, and how many are ready. Okay. Now, if I start killing these pods off, so kubectl get pods. If I start killing these pods off, the first thing you'll see is that just a little smaller. If I start killing these pods off, you'll start seeing that the replica sets will not have the current number. They have a desired, and they will start spinning them back up. So if I say kubectl delete pod that guy, right? Whatever his name is, it'll delete him. Oh, it'll get rid of him. But watch what'll happen immediately. There's already a new one that's been created. Whoops, right here. And I see his age. He just got recreated because the replica set desires to have a certain current number. Does that kind of make sense? Hopefully that makes sense for everybody, right? Like the way Kubernetes works is not that pods have any control. When a pod is dead, this pod is dead forever. He's gone. He's dead and gone. He can't start himself again. There's no facility for him to start himself again. There's a deployment, and the deployment has created within itself, because of the number of scaled resources you have, a replica set, and that replica set is what desires more. The replica set is like, if you want to think of it in like Dungeons and Dragons, you know, that's the, or in fantasy world, that's the thing that hungers. That's the thing that has some, you know, cosmic desire to hunt and create a certain number of pods, right? All right, anyways, that onion, thanks for the follow. You probably came into a certain descent into madness, which I'm sure mine is almost complete. All right, so anyways, we created those resources, and you saw those all pop up, right? And Robodom's here. How's it going, Robodom? We are just going through labs, and let's say the first thing we did was look at the root deployment. What was that file? Deployments practice file. What did you see? And what did we see? 4 config maps. And all they did was map out index.html files. That's all those things did. That was super simple, right? Like, we saw a page that was super simple. Oh, I didn't even pin this lab. I'll send this lab over to anybody that wants to do it. Here you go, and I'll pin it on the Twitch side for 20 minutes or so, and we'll go through it. So we did all the things that the lab says to do over here on the left. We just typed them out. And what I didn't show you guys is when we do the pods, we can say -o wide, and we can see the IP address of those pods. And then I should be able to curl let's say -s for that IP address, and it should just tell me that, yeah, that's one of the blue ones, and here is his basic page. And we could assume, you know, I mean, this page has a light blue background color. Sure. Whatever he has. Remember, the other ones say the wrong things for the Canary, but it doesn't really matter because they say, well, they don't say the wrong thing. They're just called yellow, and they've got light blue for the background. But okay, point is, we got this working. We've got this built. We're serving, as we can see here, web pages. Everything's good. So I said over here that we created 4 deployments. Each of them creates 1 replica set. The reason I point out the replica set thing too is because some of you can go your whole career and do Kubernetes a lot, and you will only create deployments and pods. You don't go and make replica sets typically, but the deployment does. And you got to remember, it's not the deployment that's doing the desire to make the pods whole in the deployment. It's the replica set that does it. So I think that's important to know. Okay, each of them creates 1 replica set, and that replica set desires, right? Isn't that the term right there that it says? Desires 2 pods, so 8 total pods are created, 2 per deployment. when you scale deployments, you actually edit the replica set. So when you do your scaling inside of a deployment, you'll see that happen like that. All right. So we've created some resources, but we haven't really done anything useful with them. I mean, we see that they work and stuff, but all right, so let's go on a little further. And I said, create a service that exposes the Nginx deployment blue. So this Nginx deployment blue with his pods, we can expose him to the internal cluster on port 80, and we'll name that service web-service. So if we come over here, we see web-service is going to be pointed to the blue. This is where we start. 100% of the traffic is going to be going towards blue. So let's do this real quick. Let's verify that the deployment is properly exposed and seeing the IP address, or seeing the pod IPs for the Nginx deployment blue. All right, so I give you a command that'll do this. It'll expose the deployment, Nginx deployment blue, on port 80 to the internal cluster with the name web service. So we're going to do that. And now if I do kubectl describe SVC service for web service, is actually the next command right here too. It'll give me a bunch of information, and this really is critical to kind of look through and understand if you've never built a web service before. What the web service is doing is right here, it's going to have its own IP address. So just, you could draw on your own page, or you could say the service has its own IP, and that IP will point to any number of backend pods back here for the service deployment, or for the blue deployment. So what that means is, watch this real quick. Now, instead of me saying from earlier, curl this IP address, now I can curl the service IP here, and I could give this to some, oops, it's curl-s. I could give that IP address there, or even the name of the service, which we'll do in other labs. And now I can get that. But where is that actually pointing to? Well, it's going to an endpoint, and we've got two endpoints, a 192.168.1.12 on port 80 and 192.168.1.5 on port 80. Now, what if I told you that I know that based on this selector of app Nginx blue, that it is always going to get the pods that have that same label, and these two pod IP addresses will 100% always be these two right here. So look at this, 192.168.1.12 and 1.5. There is their endpoint, so that's where the service is pointing to. And the reason it's pointing there is because the selector points to their label. So watch, I'm going to do a -- show labels. And their labels are app Nginx blue, app Nginx blue. So I'm going to do that same thing I did earlier. I'm going to kill one of those off. kubectl... actually, I'm going to kill this one off because he's the .5. kubectl delete pod, that guy, right? So he's deleted. Almost as soon as I did that, there was a new pod created. Look at this guy. And he's a .13. Now I'm going to re-show that service, right? And I bet you, without even ever having looked at it right now, that it's going to be pointing to .12 and .13. .12, .13, right there. So look at that. It's not magic, guys. It's these things all point to other things. By the way, a useful thing to do if you were trying to follow along and you're like, this guy's kind of moving fast. You might go to the history here, and you might say, like right here, you might maybe say, end of lab here, maybe, all commands, right? And then you might throw in that, what did we do? We looked at everything, right? Boom. Oops. I don't really want that bolded. And then, this is, my point is, your notes are for you guys. You guys can do whatever you want with your notes, right? I mean, I wrote the labs, so, I don't need the notes as much, but they're still valuable. I still like, having something to be able to show you guys, like, look, these are the notes around what we did in the lab, right? So I could throw all these commands down here. But anyways, these are all the commands that I've done so far. All right. So I come back up here, and I go to what do? We deployed, we exposed the service with a cluster IP service. We exposed the deployment Nginx deployment blue with a cluster IP service and verified the endpoints. Right? Do you guys see that? There you go. All right. Question on the Twitch side. I have a Ruby on Rails application under K8s, and I usually run my deployments. I get a brief period of Datadog connectivity errors. What would you suggest for me to look at to adjust the pod health? Check logic it only considers the pod healthy once the Rails bootload is indeed complete. Yeah, so I have some stuff on that, some other labs. Actually, I don't know if I ever built out the lab on that, but yeah, there's 3 types of health checks that happen inside of Kubernetes. there's the lifecycle check, the readiness check, and the wait, what is it? It's lifecycle. It's hold on. I'll tell you right here. Should be liveness, readiness, and startup. So that's what it is. So when you go to build these, the important thing to know is you've got your liveness ones. You've got your liveness probes are, this is a check to see if everything's healthy. And the liveness probe is the only one. Let me look at the names of them real quick, just so I'm not lying to you guys. Yeah. The liveness probe is the only one that can restart it. The liveness probe, if you trigger a liveness probe, it will kill your pod and start it over again. So you can do that, but typically what people will do is they'll have like a startup probe as something comes up. So liveness probe again. If the liveness probe is down, this will cause this. The Kubernetes will kill this pod and start over. A readiness probe won't do that. A readiness probe will only trigger your readiness over here. So when we were looking at these, and it shows that the pod is running, a pod will not go to running unless it's ready, right? So the readiness is like its ability to actually be a back-end endpoint, its ability to actually run a service or whatever. And then the last one is startup, and typically startup we use for startup is before anything tries to run liveness, meaning startup gives it like a grace period before liveness starts just killing it off, right? So protecting slow containers with startup probes. See, startup probes will do things before the liveness probe, because what will happen, look, if you just had a liveness probe, but it took this system a long time to come up, the liveness probe would just murder it over and over again, like at its spawn point before it could ever come up. So like a liveness probe can be very problematic in your systems if a startup probe's not there. Startup probes only run at the start. Your readiness probes run all the time, and your liveness probes run all the time. But liveness probes don't start up until a startup probe triggers, if that makes sense. So look, they talk about that all here. This is a good part to go and look at that. But I would tell you that, like, if something is, yeah, you don't want your Datadog or whatever third-party type application, because Datadog's a third-party application for anybody that doesn't know. Datadog's one. There's a bunch of other ones, but they're good tools, but you don't want them searching and checking things before those things come up. So that's kind of what I would do, is I would trigger it to not check things until they're ready, right? And then if it's watching Kubernetes and it doesn't start checking a pod until the pod's ready, you can verify that your health check is good and that you're serving on, whatever. Maybe your Ruby takes 10 seconds to come up and you need that time. This is the definition of all those things. So I posted over on the Twitch side. I'll put it on the YouTube side for you guys as well. I need to build that into a lab one of these days. I just really haven't gone around and done it. But you really got to be careful when you build liveness probes. If your liveness probes trigger, it will absolutely 100% kill that pod, and then that pod will spend that time coming back up, and then now we've got a problem where we have the same problem in AWS space as well. If you do like scale out and you have too long of a bootstrap, so your system takes like 5 minutes to build its software or whatever, and you're like, mother effer, that's way too long. And mother after I said mother effer. Anyways, yeah, so that's the thing over there. All right, so remember, this is what we're doing. We've only done this first part over here. This is how we, guys, sometimes it really helps you to draw an image in your head that this is what we've done so far. We've done it with these commands over here, right? We've done a bunch of Linux commands to get there. Let me go grab my expose command, right? When I did this earlier, there was my expose, so that's how I exposed my service. And then I looked at it, and I said, describe that service to me, and make sure that I'm seeing the things that I expect. And then remember, App Nginx Blue, that's the selector, and it looks for those labels to find its endpoints. By the way, these endpoints have triggered healthy, because if they weren't in a running state, then they would be bad. Now, we didn't give them any special, we didn't build readiness probes into them. And you say, how do you know that? Well, I can just do a more on our root deployment practice, and I can go look. I didn't give any special, like down in here, I didn't write any of those readiness things, but we could add those in a future lab. We could absolutely have that. And then we could set maybe, I don't know, we could do something that causes this to sleep or something first. And then you would see when you run this, you would not see these endpoints until those came up to healthy and were running. And that's important. This is under the hood, like how the Kubernetes works, stuff that you guys need to know if you want to be. So this is, Linux systems administration. This is DevOps stuff right here. This is like the under the hood, how everything points together to other things inside of Kubernetes, right? So now we have this Blue app, and this Blue app's doing great. It's been, right? Blue app was doing good. Blue app was serving web pages. People are happy. The company is making money, whatever. We need to deploy to the green app. There's a way, like I always, when I hear blue-green deployments, it always like kind of sticks in my head. I'm like, well, blue looks good, so maybe we're going to blue. But just remember that phrase that everybody says, go green, right? You go from blue to green. Because like I always think in my head, I'm like, well, green is the good one. Green is passing now. Green is the acceptable one. So, and then I get confused. So the easiest way for me to remember this is the service you're on is blue and you're going green. I don't know how else to say that. That's how I remember it. Go green has nothing to do with services and technology. It's just a term people use a lot, like go green, throw your recycles away or whatever, right? This is the idea. I've explained this before, and it'll make more sense in the next lab, but this is not the way that we do this in the business world a lot. This is how we do it in like this is like I'm sitting down and I'm like rapid prototyping with a team, like we're doing agile stuff, right? And we're being agile and we're actually using the term correctly. And they are like, Scott, we need to flip to the other side. And I go, okay, I'll flip over immediately. A blue-green deployment is perfect for that. But this is much more of like a back-end developer type way of doing it. And it's like a rapid prototype way and like your team's working together. This is not a way that we do this in prod. The other way that we deploy things with like a Canary or a one-box deployment, that's going to be our production way of moving things. This is a rapid cutover. We are going to cut over in 1 second, and we are going to be on green. In fact, I'm going to prove it to you by doing this. I'm going to open a new tab over here. And on this new tab, I'm going to make it just slightly bigger for you guys. And I'm going to say kubectl, describe service. What do we call that service? I don't remember what it was. Hold on. Web service, right? So kubectl describe service web dash service, right? And then now I'm going to sit over here and I'm going to say while true, do curl dash s, so we don't see anything else. And let's grab this front end IP, Control Shift V to paste it. And then we're just going to grep over here for anything blue or green. Right? Just like that. And we're going to sleep to done. So this is immediately just going to be going like this. Blue, 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 just like that. So if you want that, right, this is, so testing, we'll say testing the service cutover. If any of you need that, I guess I'll just drop it in here for you. Oops. There it is, right? It's the simplest little while, and you might say, why didn't you do watch? Well, because I want to see it cut over. Watch will do a cool thing, but watch will wipe the screen every time. I want to see it go up the screen. So now we cut back over here, and that's going to keep running in the other window. And we're going to go, we've done all that stuff, all those checks. And I say, let's verify the labels and change the service to point to green. So we are going to now change from blue as our selector label to green. And then watch what happens here. So I'm going to describe the web service. There it is. It's pointing to the blue side of things. Those are the IPs we saw earlier. Also, we come over here, and it's finding a blue page every time. Just keeps getting blue pages, right? We come back over here, and we're going to edit the service. And all we're going to do is come right here to the selector and change this from app nginx blue to green. Escape :WQ. And as soon as we could do that, this is starting to pop up green now. You guys see that? Now it's finding the green page. It cut over just like this in 1 second. The reason we tend to not do this in a production environment is this. Before you ever do this cutover, this guy probably got regression test. He probably got smoke tested. So regression test means he works with all your past tests. Smoke test means you turned him on and no smoke came out. You probably did the basic load test that you could, but there's no way to really prove out in a dev environment the types of things that your actual users will do. Your users are just the worst. Look, we need users and we need customers to pay the bills and keep the company running. But I'm telling you, they're going to do the most weird shit to your technology. So cutting over like this is dangerous because people are going to do things that you can't plan. We used to joke around about if you make something like user-proof or idiot-proof, they'll make a better idiot, right? You can't user-proof something, which is why the other one that we're going to go to, which will be like the one box or the Canary testing, you'll see like it makes more sense for the load. But in this case, we cut it over. We see here that it cut over immediately. And then now we come down and we look at the service again. Whoops, I'm not going to do it on this side. I'm going to look at the service over here. And now he's pointing to the 1.7 and the 1.8, so he's not pointing to the old endpoints. And if I go and look at those pods, here's the 1.7 and 1.8 right there. And now his selector is app nginx green, which makes those two his correct endpoints. So when we hit check and it says, look at you solving Kubernetes, you solved this challenge. Well, you just walked through it, right? But you cut over immediately between two services. Now you might say, well, Scott, can you cut that back over? Yeah, watch. We'll just make a little space here. We'll come back over here and we'll say, you know what? It broke. We need to go back to the old version. Scott, go back to the old version. Quick. My team's going to keep testing whatever. This is why you don't want this in prod, right? I go back to blue right here and we're immediately back on, we're immediately back on the blue pods. See that? As fast as I could switch that over, I'm back on the old pods. And Adobe Acrobat's over here being thirsty on my other monitor, going, hey, can I be your default? I don't need you to be my default, Adobe Acrobat, thanks. Of anything. All right, so you guys see that? So this is a really simple little exercise, but the more you think about it and the more you kind of spend putting in your commands, the more this will kind of make sense. So we got all of our stuff. Then we exposed. We came down here. We exposed the new service, right? We described that service, right? So these are all the commands I did down here through that lab, right? Oh, we looked at the pods, and we also looked at them with the show labels. And we did that so that we could compare what was being shown as the endpoints in the web service with that. So, or the web service, yeah, it's a web service. And then we cut it over. So we edited the web service and we did a changeover. And then we looked at the green ones. So we described the service. And if I had never done a single bit of Kubernetes before this lab, in the last half hour now, we have done all of these things and looked at this model for cutting between the current service and the new service of whatever type that is. Now, in a little bit, we'll jump over. In fact, the lab that's sitting behind here is my Kubernetes 3-tier application deployment, and we'll look through this. But when we get to here, we're going to get down here eventually, and we're going to have some back-end service. And we're going to have an app service that's going to point to that back-end service so that the Nginx ingress controller can just point to it. And you may think, when we're doing this lab here in a little bit, you may look at it and think, well, Scott, couldn't I do that same thing we did in this lab where I point your app service over to my new pod? Yes, you could. Yep. All of these things point to other things, and all of them work together. So we'll get there. If we get there, we'll get there. So that is kind of our end of lab. Let me put that all in a little bit so it's all underneath this lab. But that's all the stuff that we had to do for this lab to build out and deploy a blue-green switchover inside of Kubernetes. So if you've never done that before, now you can say you have. If you want to get into DevOps and you want to better understand how Kubernetes works, I'm going to admit this one isn't the basics. The basics you kind of got to have picked up already. If you want to learn where to get the basics in Killercoda, you come over here, and here's all the basics right here. The CKA, the CKAD, there's a whole bunch of, there's like literally about 150 labs here of the basics. There's the CKS, I've got labs and stuff. I've got talks and presentations in our Discord that are all about doing this. So anyways, there's the basics here if you want to go learn about them, right? Because again, we're kind of running today. All right, so that lab's done. That lab was good. Now I'm going to say lab 2 for the day is going to be Canary deployments. So this will be Canary or one box deployments. That's what AWS calls them. And here's the lab for it. So I will link the lab over here. And Chris Johnson, how's it going? Hopefully this stuff's useful to you. I'm going to link this on the YouTube side as well. So you guys can be in the same lab as me right now. It's free. They don't cost, like, Killercoda, I think, is the best free thing on the web for getting your hands on this stuff. If you struggle and you're like, I need to get more hands-on time because I don't get that kind of time. Well, here you go. I've literally, like, and you guys say, oh, how free can Killercoda be? Guys, I have, like, abused Killercoda. And what I mean by that, like, one, I have 61 labs I've written up there. I have probably launched well over, if I had to guess, 3,000 of their environments here, maybe even more over the last years. They've never charged me anything. Now, when I say abused, I mean, like, I use their environment a lot, and I get you guys to use it. And I think I've shown you guys, we can see how many times people have launched different labs of mine. And it's 6,000-7,000 times a month people are kicking off just my labs. They have all kinds of other labs too, and it doesn't cost anything. You just log in with either a generic email or you use I just use my Google Federation. They don't even email me. So I think they're the best free thing on the web to get your hands on a system. All right, so we've got all that going, right? This next one is going to be, so I linked the lab to you guys, and let's go see what this lab's going to ask us to do. I say inspect the deployments practice YAML file. We'll do that same thing again. We'll say run this file and inspect its resources it creates. Mr. Muddy Pants said, how does Killercoda make money? Well, it's funny. They do have a paid for version, which if you come up here, you can pay them like $9 a month or something, $9-10 a month. But there's another aspect to this, and you say, well, how do they make money? They are the back end. Let's go to Killercoda, because that is an interesting question. How do they make money? They are the back end resources of what's called Killer Shell, which is a paid for service for people who are going to go take their CKA. So I think I actually suspect, I've never talked to Kim Woosterkamp about it, but he's the guy who runs it. He's the guy who runs the whole project. I'm pretty sure this is just their excess resources on the back end of what they do from Killer Shell. So Killer Shell, if you've never seen it, this is how Killer Shell works. You get ready to take like a CKA, and you come in here and you buy their simulator. So let's just say I logged in here. I haven't been in here in a long time. You can buy their different simulators. In fact, I may have, I don't have any of their free simulators anymore, but I sometimes have their simulators. Sometimes they do, when they got ready for their FCS, they opened it up as a beta, and you could sign up for their beta. Yeah, this is their backend. So they make money by being part of the Linux Foundation exam simulators. They're the standard ones when you go to take those tests that they give you. So these things cost money, but this backend free of Killercoda, it's all free. And it comes from, I guess there was a thing before, I was never part of it, but Catacoda, and that was something I think that was run by O'Reilly before they were bought out. But let's go. I mean, for me, like, we're going on about 2.5 years, I think almost 3 years of me running labs out here instead of just doing my own home labs. I still have my home labs that people can use, but the free labs out here are the right price. So let's open this image in a new tab, and let's go look at this. This is a Canary deployment, or some people like to call this a one-box deployment. But this type of deployment is really the way that you want to do things in production. So what's going to happen is, at the beginning of this right here in step 1, we're going to stand up our services. We're going to do a deployment of an exposure of a web service the same way we did before. In fact, the beginning of this lab starts exactly the same. All our traffic is going to Canary 1. Then we are going to say, okay, for production purposes, we want to get ready to expose Canary version 2, the second version of our app, the green, if you want to think of the blue-green from earlier. But when we do that, we've done all our testing over here, and we want to only expose a little part of it, but to real, actual production traffic. So when we do that, we're going to scale up Canary version 1, which is the running one, and make it real big. And when we do that, when we scale this up, the user doesn't see any difference, and this is our app that's been running forever, so this is safe for us. We probably even have services that do this when we're under high load and all kinds of automation stuff, but that's fine. We're going to scale this up, and then we're going to put a little bit of the traffic over to Canary version 2, and we're going to do that at an 80 to 20 rate. So an 80% of the traffic's going to stay over here, and 10 or 20% of the traffic's going to come over here. And you're going to say to me, Scott, how do you do that? Well, if we had just taken this right here and cut it over, by default, the tool would say, well, 50% this way and 50% this way. But because we scaled up Canary version 1 to have 8 out of every 10 parts, and they have 2 out of every 10 parts, the natural load balancing that will occur will be about an 80 to 20. Does that kind of make sense? Hope it does. And then when we're ready, when Canary version 2 has proven itself out under a certain amount of load, and it has not failed customer transactions, and we've done all the other regression testing we could think of, then we pop over here and we go 100% to version 2. So this is a thing that I tell you guys, come in a lab, the same thing I tell my college students, come into a lab, look at what you're doing, step back for a second and go, okay, this lab wants me to, not like the last lab, and sometimes we compare things to other things because that helps our minds remember. In our last lab, we simply went, hi-ya, and we went from right here to right here. We went from step 1 to step 2, or step 3. But in this lab, we want to do it a little slower, a little more controlled, a little more testing that the second version of the application is good. Now, you guys are probably thinking, well, Scott, all you're doing is serving out a web page. That's the silliest little thing ever. Yeah, the web page is demonstrative of whatever is behind that web. That web page could be a load balancer. It could be reading a new database instead of the old database. It could be any number of things that we wanted to change. And we can even then automate this process later. All right, well, anyways, but the point is we got to do the basics. We got to crawl before we walk, before we run, right? And in this sense, we're crawling and doing this individually. Even though, again, the basics of Kubernetes, I assume you already know. All right, so what are we doing? Let's go look at this deployment file. It's the same file as before. We've got the blue and the green. We're not using them this time, but they're going to be there. And then we get down here to yellow. And yellow is Canary version 1. And yellow 2 is Canary version 2. Again, don't worry about the background color of the actual page. It's a moot point, right? Or if you ask Joey, it's a moo point. It's a cow's opinion and it doesn't matter. I know, bad puns. But anyways, this is what we're using here, the yellow. So then we come down here. We're not going to use the deployment for blue or green, but we are going to use the deployment for Canary and the deployment for Canary version 2. And they are simply going to point to the original index.yellow or index yellow and the index yellow 2 version 2. So that's how our Canary maps, right? So we see all that and we go, okay, looks like those resources are going to be built. Let's go deploy that. This is very similar to our last lab. We deploy, the only things we really care about are these two and these two, but the other ones, I just didn't want to edit the file, so that's good. We get our config maps. There we go. We get our deployments. There we go. And then we get our pods. And here's our set of Canary pods right here. All right. So we have all the basic pieces for this right here. Now on the next one, we're going to build the web service. So we do a thing called exposing the web service. So we're going to expose the deployment Canary on cluster port 80 and name it web service. So we do that. And then when we go and we look at that service, we're going to see that it's pointing to this 1.10 and 1.11 address for the pods, right? Then we go look at the pods and we see that 1.10 and 1.11 are being shown as the actual regular Canary, not the Canary version 2 deployments. So that's good. If I really wanted to, then I can curl -s this front end endpoint, and I should be able to see if I just, we'll just curl the whole page. But if I were to grep-v, grep-i for Canary, I would see that. I could also, if I was so inclined, I could also do only this pod here. Oh, yeah. You can hit Control-Shift-V in this window, and that would show me Canary, and so would 10, right? But it doesn't make any sense to do these ones because these are directly hitting the pod, and like I told you guys, the pod's ephemeral. Somebody could delete this pod. kubectl, or the process can even kill it, right? Who knows? Delete pod, that guy. And then now that pod's deleted, and now this doesn't work anymore. And this other one still does, but the one that will always work is the actual service. The service is now pointing to those pods. So let's describe the service again. Describing the service will show that it's now pointed to a new one. It's 11 and 12. And if we go and we look at the actual pods right here, you'll see that there's 11 and 12. So that new one that just got built is being represented as an endpoint of this service. All right. So everything points to everything, and everything kind of works. And now the last part is we're going to scale the deployment up and cut it over. So we're going to get ready to do this part. But I need to take a real quick break real quick. So we're going to take Hourglass, and we're going to say real quick break. Quick break. And then more Kubernetes. I'm going to take 8-minute break. I'll be right back, guys. Robodom, if you're still around, you're in charge. I think Robodom's here. Take a real quick break, guys. All right, I'm back. We'll just hang out for a minute in case anybody took a break. I don't want to cheat anybody out of their break time. And as I always ask on these days, what's everybody working on this next week? You know, it's a Monday, right? Tomorrow's Monday, so you always got to think about, what am I doing? There's an old saying, start Monday, never miss a Monday, right? So if you didn't study anything the last week, that's fine. Get back to it, right? Like, this is same thing I tell my college students. You didn't do all your stuff all this weekend, that's fine. Get back to it, you know? That's what we do. Robodom, yeah, Robodom had to go do work, so apparently he won't be around. That's okay. So we're looking at this, right? Still on break, but we're going to cut over. We're going to scale this one up, and then we're going to make it straddle both. That I'm working on some sensor data collecting deployments in Kubernetes. Nice. Are you using Prometheus for that? I got to get back to studying my PCA. I plan on taking my PCA before the end of the month, so... Cuttlelingus, Ansible, and RHCSA. Nice, nice. Cuttlelingus, did you make it around for Ash's talk yesterday? I don't know if you were around. He was talking about Ansible quite a bit. Oh, you're using Telegraph and Timescale? Okay. That onion, nice. Yeah, Ash has been around Ansible since its inception, so he's been around a long time. Yeah, he didn't even get super technical. He was just kind of telling you guys where he'd have been and kind of the stories and stuff. But yeah, he's a super technical resource that can really help you guys out if you are looking to get into that kind of stuff. Yep. Can do anything he wants, and he goes and sells Ansible automation to people, which is, you know, probably pretty good money. So probably pretty good money over there. And he does that for Red Hat and IBM, obviously, you know. Mr. Muddy Pants said, have I heard of the GitHub repo Kubernetes the hard way? I have not. This looks like it's Bootstrap. Yeah, I mean, I've got nothing wrong. It looks like this is a little dated. That's fine. So let me tell you guys something. And we were talking about this yesterday. This is something that Ash said yesterday in his talk. He's the guy who's a Red Hatter. And then me, I've been around for 20 years too. We both had the same experience coming into Linux. And it is this. You get a CD thrown at you. He actually literally said this yesterday. He said, you get a CD thrown at you in a book, and they say, put Red Hat on a system. And you've got a week to get it all set up or whatever. Well, in my experience, it was like, basically, hey, Scott, get this Red Hat working on this old server because we need to fix this deployment of this other thing. And, like, you just had to figure it out, you know. And if you couldn't figure it out, you just couldn't be a Linux engineer. That's the way it used to be. Well, my point in saying that is it's the same thing with Kubernetes. If you have to stand up Kubernetes from scratch, I bet a lot of people will not do Kubernetes. I'd be willing to bet most people wouldn't do it. Like it would eliminate 90% of people right off the bat. But if you have a place where you can drop in and start doing Kubernetes things, you could kind of ease yourself into it, and then you could realize, hey, you know, the deployment stuff will typically be automated by the time I get there, or I can find automation for that. So the raw deployment of things might not be nearly as important to me as understanding like how the individual components work. So anyways, that was kind of a thing. Yeah, I thought Ash did really good Cuttlelingus. I really liked him, and I've worked with Ash for many years now, probably close to 8 or so. And he's always been good. He's always been like a fun person to listen to. So I tell people that his stuff's all really good. So, all right. So let's get to this next part here. We've got the first part of this stood up. We've got these things there. But before we go to this, we've got to scale the deployment up on the left side. So let's scale that up. Let me get rid of that for now. Let's scale this deployment up. And the way we're going to do that, right, we do kubectl get deployment. right? All our deployments are there. And we're going to scale up deployment Canary. And then if we go look at deployments again, look at him. He's got 8 that he wants now, right? And he's got 5 available. But if we give him just a few more seconds, they'll all be up. Now, if you guys also recall, I told you that there's a replica set, so RS. And the replica sets are really what get changed underneath the deployments to do this idea of adding more or less, what we call scaling in or scaling out, right? So we scaled the deployment up to more replicas, which is kind of a scale out if you think of it horizontally. And then now when we describe the service, watch this. Without changing anything else, because we have app, web, and version equal to 1, we will now have these 3 plus 5 more, right, of these endpoints, and those are all pointed back to those pods. So we have done this first part right here. But now we need to do this next part, and when I go to do that, I'm gonna do the same thing I did earlier. I'm gonna come over here, and let's grab this IP real quick, and I'm gonna come over here and I'm gonna start a little while loop. And if you guys want to start this in your own new tab, I'll give you the code here in a second. It's while true, do curl -s against this guy, and then grep -i for canary, right? And then sleep 2, done. And that's just going to show me over and over again that we are hitting canary 1, right? So I grab this. If you guys need that code, or, well, you know, it's a little bash one-liner. There you go. Boom. All right. So that's running. We come back over here. And by the way, you can't tell which of the 8 it's going to because they're all the same web page on the back end, right? But it's hitting 1 of 8 right now when it hits that deployment against Canary v1. But now we come over here and we're going to edit that service in such a way that we're going to take off this version 1 here. I'm simply going to go and delete it. So now the only selector that this is looking at is just web, and that's going to give it 10 things to look at, 8 of them being the initial Canary version 1, and 2 of them being the version 2. So now watch this. It's going to be about an 80-20 split. Wow, that's going a lot for version 2. But it's going to be about an 80-20 split right here. So we'll just watch it for a little bit. A lot of version 1s, a lot of version 1s. I'm surprised we had 1, 2, 3 version 2s in a row. 4 of them, actually. But look at all those version 1s, because, again, we're straddling 10 complete back-end pods. And then we're hitting 80% of the time version 1 and 20% of the time version 2. Very good. All right, Nourishing Soup, thanks for the follow. You guys want to see Ranger? How's Ranger doing? We haven't checked on Ranger today. How's Ranger doing? What? Ranger cam's down. All right, I gotta go fix Ranger cam here in a minute. We'll do it here in a second. I'll give you guys another break. But we are currently fully right here at an 80-20 split. Do you guys see this? Right here. We're seeing a lot of version 1s, the version 2, 2, 1, 1, 1, 2, 2, 1, 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Because again, it's 80-20. It's an 80-20 split. So look at all these 1s. But then some traffic's going to go over to 2 here soon. We'll see. That's a lot of 1s in a row, right? But that's fine. There's a 2. So now if we were thinking about this, and this was our newer app over here, it's taking some load, it's taking some requests from real customers, but all the rest is still going over here. And then after we've had a proper amount of burn-in time, or 1 box running, or Canary test time, whatever we want to call it, then we come down here and we edit this web service. Oops, we don't do it in that window. We do it over here. And we're going to edit that web service. And we're going to add down here again that version back. And the version's going to be v2 now. And as soon as we do that, we're only pointing at version 2. and we come over here and we are only getting version 2 now. Do you guys see that? So that's the component pieces of how a blue-green deployment works in our old lab and how a Canary deployment works in this lab. Right? All version 2, look at it. And oops, we don't want to do that over here. We want to do it back over here. And we can see that those are the pods for version 2, and here they are on the back end. 6 and 7, 6 and 7 for their IP addresses. I'm just saying the end of the last octet because it doesn't really matter. So. Yeah, Cuddlingus, they could be anything. Yeah. You can point. You could have the service point to anything. The service is just a front end that will always be there, because then now, like, think about this. Like, remember I was killing these pods earlier, and as I was killing them, they were coming up with new IP addresses. Well, that's a moving target. That's what we call a moving target. That's just something that, how would your service know to point to it? So we don't point our service to that. We point, or a tool or whatever. We point our tool to this, and we do it by name typically, which I'll show you in other labs. And you will always then point to web service. In this case, that's a generic name, right? Web service will always back end the correct things or nothing. But if web service were down, that would be indicative of something else being wrong, because web service itself simply points at the correct things. That's all it is. Oh, I didn't know that about Windows containers. I don't think I've ever run, in all my time doing Kubernetes and stuff, I don't think I've ever run a Windows container. Yeah, I don't think I've never even deployed one. I don't think I've ever done anything with Windows, but that is interesting that it can't be a GUI-based app. But anything else that can be pointed to over IP, you can do. Yep. So the thing that I would spend time with, if it were me, I would say, do I understand this? Like, at a high level, do I understand what's happening here? Don't just take the technology out for a second. We've got a deployment here which has some pods, and a deployment here that defines some pods. And this is the one that everybody's currently hitting. Like, all their customers, everybody goes to this one. But they don't go directly to it. They hit a front-end web service. This is what we call a reverse proxy or a load balancer. And this device is always happy. It's a service that we've defined, and it just sends data here. Then I want to make a new service and prove it out. So I do this, and I tell that front end, people are still just hitting right here, and it's going to now straddle the two different things. The split of them is defined by me, by however I scale them. And then when I'm ready, I cut it over, and then everybody's on the new one. That's it. That's it. That's the whole thing. Nothing sneaky there. So we hit check. Validation successful. And then I like to do a history. And then I come in here and I say, what did we do? We checked out the deployment file. So checked out. Right? We checked out the deployment file. We found 4 deployments in there and 4 config maps, right? There were 4 config maps and 4 deployments in there. We deployed the deployment file. That was right here. kubectl create. As long as there's no problems, that should all work. Then we checked a bunch of things, and then we exposed the service. Expose the Canary v1 service. Deployment via the web service. That looked like that. And this, I've told you guys this before, this is what we call an imperative command. This is not the way we typically want to do it. We want to actually take this. I'm going to show you guys something here. If you were saying, Scott, I need to make this repeatable for 100 customers, I'd say, okay, let's go with this, and we'll say 8. So we'll bang 8, but then I'll say dry run equals client, and -o is YAML. So this will run that deployment, And then now this is actually the way that, and we would go put this in a file, and this file will go and it will be called a web service, just like we have. It will use the ports 80 for TCP and target port of 80 internally. So 80 is the external port. Target port internally to the app is 80 because it's Nginx. The selector will be based on this web and v1, so it'll pick that deployment, and then that deployment's pods, and then the type is cluster IP, or it could be a load balancer, or it could be a node IP if we wanted to expose it outside of the cluster, and then the status is there's no load balancer status, so that's just an empty YAML. You can always use this if you ever. So you guys know YAML is all key value pairs, and there's a little trick. If you ever have just a key with no value, there's nothing there, but you have to have the key for some reason. No, Cutolingus. Look at this real quick. Hold on. This is my history. When you bang 8, bang is your exclamation mark. When you bang 8, you say run 8. So I ran history of 8 right here, and then I added dry run client and OYAML on the end of it. Oh, I'm sorry. So then it said what I did here. This is the actual command I did. The bang 8 was me doing a Linux shortcut, right? You guys know I'm a Linux guy. That's what I do professionally. So when I bang 8, I'm calling history 8, and I'm adding this to the end. You can also do regex. There's like a sed that you can do, which will replace things in this command while you rerun it. So you can rerun a command and like change this to something else in on the fly. So that's fine. But anyways, I just want to show you guys, if you ever have an empty value, because you can't just leave this in YAML, it'll scream. Load balancer with no key pair or whatever, it'll scream. So then you put that and it says that's an empty value. So it's kind of a nice little thing, because with YAML, you're not dealing with a structured language, you're dealing with an unstructured data set of fields anyways, meaning if load balancer isn't there, it's just not there, right? Okay. So we do all that, and what do? We figured that out. We figured out how we could do a dry run. This is now a declarative command, and we can go put it into. We could put this at the end of that file that we deployed, and then we would deploy the service while we deployed everything else. I didn't do that in this lab because I wanted you guys to build. If you've never done this before, I wanted you to build this service separate. I built all this for you before the lab started, right? Built all this stuff for you, but I wanted you to build this part and manipulate this part, so that's why the lab does it, okay? Because that's probably, hopefully useful to you guys. All right. Ranger Cam. Oh, Ranger Cam, you always break after a few weeks. Let me go fix Ranger Cam real quick. Hold on. Pull up my hourglass again. I'm gonna fix Ranger Cam and grab me a drink. So fix Ranger Cam. Grab me a drink. 5 minutes. We're gonna go quick. I just gotta go downstairs. Come right back up. See if Ranger Cam fixes itself. Frickin' Ranger Cam. Alright. That camera should be back up now. All right, got a drink. There he is. Oh, Ranger. You're so old, Ranger. He's just a big lazy dog, guys. So that's my Ranger check. All right. That wasn't a real break. So, we then scaled up the second, or the first service, first deployment. How did we do that? We said scale up with more replicas. By the way, that's a skill you have to have for your CKA and your CKAD. You need to know how to scale up a deployment. And then we edited the service to point to both. And then right here I'll say remove version, edit service to point only to app 2 or version 2. And that was that, and then it was add, what was it? Hold on. So we just banged 27, right? And then, oh, version, yeah. Add version V2. There you go. Yeah, Cutolingus, you're using K8s to expose a smaller percentage of the traffic to the new app. Yep. So you control this web service service as much as you want. And when you first build it, you pointed it to Canary 1. Then we removed the app version, because see how the version 1, version 1, version 2, version 2, but the app was all Canary. So then what we did was we scaled up the Canary backend so it was just getting hit more. And we removed the label so only app Canary existed. So now we were only pointing at this app Canary, and that means that we were hitting all of these. And then when we were ready to move it back over, we put the version V2 on, and we were pointed at the new side. Yeah, so Cutolingus, if you needed to add new functionality to an application that was already running, and pods tend to be immutable, right? We don't change pods once they're running. What you would do is you would deploy a new version next to it and slowly move over to it. Have you guys ever seen that magnetic sand? You take that magnetic sand, you put a magnet next to it, and it slowly moves over to the magnet. And then put a stronger magnet, and it moves over to that stronger magnet. That's kind of like how I think of this. It's like a slow, creeping, crawling movement from the one service to the new one. So hopefully that makes sense. All right, so that's what we did. And those are things to practice and understand if you want to be ready for using Kubernetes for real. Not just, I mean, these are both valuable skills for your CKAD, but they're also things like if you tell me, hey Scott, I want to do this stuff for real out in the enterprise. Somebody's going to ask you about rolling through a deployment, and you need to understand the ways that we can do it. So those are the two ways that most people do it. All right. So, also, in this talk, when we're deploying a 3-tier application, which I can start this talk if you guys want to go through this. There's a lab that goes with this that we would do. I'll make a little poll here, right? And you guys can decide: do we do the talk now, or do we just keep doing labs? How's that? We'll do that over on the it'll be on the YouTube side, or on the Twitch side. Unfortunately, you guys on the YouTube side won't get it. So keep doing labs. All right, so what's next? Keep doing labs. Start the 3-tier talk, and I'll give you guys 10 minutes. You guys can pull that and do whatever you want. You guys can vote. You guys have the power. I will pretty much do whatever you guys want because I'm here anyways, right? So you guys can decide if you want to keep doing labs, which is just us generically doing labs, or do you want to go through the talk? The talk still has a lab. I still have a lab we're going to do with it. It's all hands-on. But, yeah. No, the talk is not more beginner. I'd say the talk's much more complex. But here's the thing. Anytime you guys watch anything, even the complex things, there's still the basics involved. So I still think you can pick up the basics. You just kind of have to watch for them, you know? Yeah, I tell you guys all the time, you know, Cuddlingus, if you haven't heard me say this, I'll say this, but like if you had two friends that were, you know, killing it in the gym and you're like, man, I want to start going to the gym too. And you're like, hey guys, will you take me to the gym with you? Or, you know, hey gals, I don't know whatever any of you are, but hey guys, take me to the gym with you. I guarantee you, they're not going to sit you down for 6 hours in the locker room and explain to you the gym. They're going to simply tell you to follow them around the gym. Like, hey, let's go do this. Let's go, and then you're going to be sore for like the first couple weeks, and you're not even going to know why you're so sore. You're just going to be sore, and then over time, you're going to start to notice patterns like, hey, you know, I'm sore upper body push, and then I'm sore upper body pull, and then now my legs hurt because we were squatting a whole bunch, and then, you know, over time, you're going to be like, oh, there's a pattern to everything we're doing. We're doing push and shoulders one day, and then we're doing pull and back another day, and then like. We're doing arms just one day. We're just hitting arms. And then we're doing like all squats the other day. There's so many squats. If they're good gym partners, they're going to be showing you how to squat, right? Because squat and deadlift are your two real measures of strength, if you guys don't know that. But anyways, they bench was fun when I was younger, but bench didn't really show how strong you were. You know, you had to have a 600-pound squat to make people really notice you, right? That kind of stuff. But anyways, where I'm going with that is... It's the same thing here. I think getting your hands on this stuff and doing this, even if you don't understand it at first, is still you're looking at what's happening, and over time, as you go read things and see other pieces, it'll start to come to a head, as it were, and you'll start to understand some of it. So, okay, we got a few more minutes on the talk, so let's check on Ranger Cam again. How's Ranger doing? Ranger is in full lay down mode because he's tired. Let me show you guys some other stuff. This one, let me show you guys some stuff. So you always have in our Discord, you know, you got different streamer schedules coming up, me and Fisherman typically, and then you've always got more events coming. We have one that's actually going off in about 4 hours, but Salty Catfish is sick today, so this one might not happen. He mentioned earlier that he thinks he caught the flu, so feel free to hang out at this time. You know, you guys are always welcome to hang out in the Discord anyways, but he might not be around. One of the other guys might help. I don't know, but yeah, he got sick, Fisherman, because of his kids, right? Anytime you got kids around. Sorry, I'm munching on some Reese's Pieces over here. This will normally happen. And then starting next week, wow, 60 people say they're coming. All right, we'll see if we can break the server. But we're going to have a 16-week Linux Systems Administration course. And I've got this course kind of dialed in now. And then I just got to keep building out the weeks as we go. You will have to, if you're going to do this thing for real with me, you're going to have to do discussion posts. You're going to actually feel like you're in college. And then you're going to have a project you do for me. And that'll be fun for people, I think. Or it might not be fun, but we'll see. But it's like Linux systems administration. It's like getting in and doing this stuff and getting ready to do it professionally. So that's all coming up. All right. Ranger Cam. We're going to burn down. Yeah, Mad Monk. I've been trying to burn that server down. I've been trying to find the limit of Discord this whole time. And we found one at the beginning of August. I didn't know that when you have more than 25 people, you can't be on camera anymore. I didn't know that. We found that out, though. All right. I'll quit munching too much. But it kind of looks like you guys are going to want to. So lab 3 is going to be, so this will be 3-tier talk. And this will be lab. So the lab for the 3-tier application is right here. Lab is here. So I'll give it a few more minutes, but it looks like the 3-tier talk is winning unless anybody spends some channel points to keep doing the labs. All right. Let's give that a few minutes, and I'll let you guys keep deciding if you want. You guys have the poll. You can decide. Also, there's always Discord. You guys are welcome to hang out down in Discord all you guys want. So. Pull this down over here. All right. If we're going to do the 3-tier talk, which is fine, I won't have this one just going until we get to the part where we're running with it. So just remember, you don't have to start that. I wouldn't start that lab up until when I start it, because you only got an hour for free, obviously. So we'll do that. All right. So we're waiting for this poll to end with about 2 minutes left. And it looks like people want to do the 3-tier talk, at least for now. Unless Fisherman swoops in with a whole bunch of channel points at the end here, which he's been known to do. All right. That's still running. Ranger's still dreaming. What I would ask you guys to do, and you don't have to, you don't have to use a tool like I use. You can use any type of notepad, any of these types of things. This was from our discussion yesterday. You can use any tool you want to take notes. But I advise people to take notes, right? Like anything worth remembering is worth writing down. It's something I learned in a master's program. I think that that's actually true. I think writing stuff down helps your brain remember it, even if you're just typing it out. So I think there's some value to doing some of this. Even some of the stuff I was doing in that lab that I haven't done in a while, because I wrote those labs a while back. Retyping some of that out helps me remember it, and putting it into my notes means that I can go grab it later if I need to, So I think that's kind of valuable. All right, we're down to, I think, about the last minute of that poll, so then we'll go. I'll sit here and eat some more of my Reese's. Voting's almost done, it seems. Let that thing count down to the final. All right, 3-tier talk looks like it won. So we're going. So I originally gave this talk, oh wow, a year ago. This is a Kubernetes 3-tier application deployment. It is not from the software engineer or the front end engineer view of things. This is from the Linux engineer turned DevOps / Kubernetes guy, who I can get this stuff running for you, and then what you're going to do on top of it as an application is up to you, right? So this is going to show you guys how we deploy it, and then it's going to turn around and show you how we secure it. Okay, so if any of you are, again, I'd take notes. If it were me, I'd take notes. All right, so quotes get you interested. Edwards Deming said, if you can't describe everything you're doing as a process, you don't know what you're doing. He was a guy who, after World War II, went over and really turned Japan into the production type powerhouse that they are. He was real big into TQM, which is total quality management, and it's a type of continuous improvement principles that basically he founded. So Edwards Deming, if you ever study him, he had his Deming's principles and all these things, but one of his famous quotes that I always liked was, if you can't describe what you're doing as a process, you don't know what you're doing. So if you're like, I just go like this and then you shake your hands around and then it all works, well, I'm sorry, you simply don't know what you're doing. And then another one is, containers don't solve all problems. I know people think they do, but they don't. And then the boss coming in and just saying a whole bunch of techie things. You know, this is like when you watch Fisherman Guy Bro stream and it's just all tech talk, right? I'm just kidding, but anyway, I don't even think Fisherman's around. But if he is, there he goes. There's his zinger for the day. Yeah, just put it in containers and then Kubernetes, right? Like it doesn't save. Like, you can't just say things. Like, you can't just be like, we'll move it to the cloud. Why? We'll put it all up in the cloud. All our datas will be in the cloud. That's not even the right way to say it, right? It's all your data. Data's already plural, guys. All right. So here's the topics. We're going to talk some basics of Kubernetes. We'll talk some certification paths for people that want to go get their stuff, their pathing and that kind of stuff, and go that route. We'll talk about deploying a 3-tier application. We'll actually deploy it in that lab. So we'll do a front end with Nginx, and then deployment of an application in Python, specifically with a tool called Flask, if you guys have never seen Flask. Then we'll deploy a database in MySQL. Yes, the database will be a pod inside of Kubernetes. And some of you would go, I would never run that in production. That's fine. You could just be etching out a 3-tier application for a POC, a proof of concept, right? So whatever you're going to do there. Then we'll talk about securing the application. We'll do some deployment best practices. So for securing an application, there's some things that don't get done by default that are super easy to do that make your containers, I hate the term like making it bulletproof, but it's kind of making it, let's say it makes the pod, it makes the deployment much more resilient to the types of attacks that somebody might do against it, right? So we'll talk about image management, immutable containers, and non-root processes. And then we'll do some networking best practice, which is applying network policies to limit communication so only the components that should talk to each other do. Zally Panda, we are not doing networking right now. I do network engineering sometimes. Right now, we are simply doing a 3-tier application deployment inside of Kubernetes. So that's what this talk is about. And you guys voted for it, so this is what we're doing. So if I were taking notes, this is what I would write in my notes. When I'm done, I should understand the components of Kubernetes. I should know where to go for more information. Understand the certification process for Kubernetes if I want to get certified, and know where to go if I want more information about that certification. How do we deploy a 3-tier app and then do that in a secure fashion? This will be the bulk of the talk. How to update a 3-tier app while it's running. So you'll see some updates of things as we kind of go. And then apply networking policies and best practices to security in a Kubernetes cluster. K8s is just Kubernetes. Out of scope, we won't be focusing on the code. Again, I'm not guys, I tell you, I'm not a coder. I can write stuff, and I can make stuff work because I understand computer science, but I am not like a guy who writes code all day. That's not what I do. But my stuff works, that's good. But and anything here is, you can go use it if you want to. It works, but what I'm doing here with the code will not be the focus of what I'm showing you guys. I'm coming from the low-level systems engineering and running the Kubernetes. Other people are focusing on this from the top down and thinking about what their application could do. But you could take anything I show you here, throw a whole bunch more Python in it if you're a good Python engineer, and build out whatever you wanted to for anything that deals with Python inside of this app. So you guys will get there. We'll get there when we get there. But we're going to actually pull information out of a database, and presumably we can put information in there, but we don't do that in this one. Again, that's one of those things you could do if you wanted to later. All right. So Kubernetes. Why Kubernetes? Why do we use Kubernetes, right? Docker's great, but everything's manually set up. So if I have some Docker container and I want to expose, port 80 on the container, the external port's going to be 8080. And then when I go make a new container, some of you guys have probably run Docker and know this is true. When I go to run a new container and I want that one to also be port 80, maybe they're both some app that I've designed and I want to go see it on port 80. The external port for that, I have to manually map to a different one, like 8080 and then 8081 on some host, like on my machine if I'm running them locally. Well, that's a hassle. Keeping track of which ports are open and all that kind of stuff, that's a hassle. So what Kubernetes does is Kubernetes says, well, what if you had to do that on 10 servers and productionalize it? Well, now you've got to run 8080 and 8081, and then you got to make sure that that's not there on the other nodes. Well, what Kubernetes does is it says, you know what? You just go ahead and tell me that the Docker, the port that we're going to point at is going to be 80, and I'll do all the external port stuff myself. Now, you can manually set that if you want to be a glutton for punishment, but that's not required, right? So Kubernetes handles all this other stuff for you. And I think as I keep showing this will make sense. But right here, yeah, sorry, I'm going to show this here in a little bit. But my point is, if you were trying to deploy this on a bunch of servers, you would have these breaks because 8080 and 8081 are already used, so you can't have another container listening on that. So this would break. So what Kubernetes does is it's got this idea that you've got a control plane node, which we used to call master nodes. And then all the nodes that didn't like answering to a master node got mad. So now we call it control plane nodes. But you will still see in some older documentation master nodes, and that's where they come from. Then you've got worker nodes, and the worker nodes are out here doing whatever they're doing. But every single node, regardless of its name, is running the kubelet process. The kubelet process talks to other nodes via certificates over your Ethernet network. Okay, this is important. And there's all these overviews and different things. This is up in our Discord, by the way. So if anybody wanted a copy of this presentation, it's up there in our Discord under presentations. Then all of your systems define their own logical software-defined network, and that software-defined network that's out there running is going to be controlled by within the kubelet process. There's actually, you're going to have a pod that's typically running that, or a set of pods that runs that. But then they're all going to use that for inter-pod communication of your different traffic. Now, this is logical in that it's still traversing the real Ethernet network, but logically it's a separate network that your devices are listening to, right? Over on your control plane nodes, which can be one or many if you're in a highly available system, you're going to have what's called static pods. Static pods exist actually in a directory on one of the nodes. It's in etc Kubernetes manifests. So /etc /Kubernetes /manifest. You're going to have the definitions of these, at least these 4 pods typically. Then you're going to have other pods that are doing things like core DNS, networking, other stuff like that. Then over on your worker nodes, you're going to, from API calls. API calls are going to be coming into your control plane node, typically against your API scheduler. And, or sorry, your, where's your API? API server here, sorry. So they're going to hit the Kube API server. The Kube API server is going to go talk to the controller manager, and then the scheduler is going to schedule jobs to go places, right? So let's say you deploy some deployment. He's going to create a replica set, and then he's going to have as many dynamically assigned pods on that worker node as he needs. This is exactly what we were doing in that last lab, right? If you build a service, the service will exist over here, and the logical network, software-defined network here, everything will talk to that service to go see where the backend pods are. So that's all going to be maintained, and then everything's going to talk, right? It's a very high-level pieces of it, but you can go look at any of these things right here. You can go verify by just going into Killercoda. So when I tell you guys Killercoda is great, this is what I mean. You can go right in here. And if you've never done anything with Kubernetes and you just wanted to verify I wasn't lying to you here, you could go on this box. Here's the, I'm going to pin the lab for you guys if you want it to. Here's the lab. This is the one that I'm actually doing. And we're going to say kubectl get nodes. And I see a control plane and a node 01. So my control plane and then a worker node that could be named whatever. I see that they're ready. I see that there's one with a role of control plane. And then these other ones, it's version 1.30. And I can say, well, hold on. Scott said there will be a service running called kubelet. Kubelet's running. User bin kubelet. SSH to node 01. And ps-ef for grep-i for kubelet. There's kubelet running over there. He wasn't lying. Everything's doing something, right? So anyways, we've got these pieces here. All right. Let me come down here a little bit, and then Kubernetes basic. How does it work? We no longer configure the Docker directly. We no longer run Docker create and then set up a node manually. We define pods to one-to-many containers, and they get placed together on worker nodes. We no longer do anything with the networking directly. The software-defined network deals with that. It does it for us. All pods in the cluster can always communicate with all other pods by default, and we will change that in the security section of this, okay? All pods can land anywhere with capacity unless reservations, taints, or affinities affect them. These are almost like the hard-coded tenets of Kubernetes. So there's some other ones, but these are the ones that are relevant to this talk. These are true. Okay? So, certification real quick. This is an aside, but if you're like, I want to know more about it, but I don't want to, you know, I want to learn how to learn more about it. This is what I would tell you guys to do. Let's say you want to know more about what I'm talking about here, and you're like, okay, this talk showed me a lot of stuff, but there's all these gaps now, and I took all these notes, but there's all these gaps, right? Well, you might come to like the CKA, Certified Kubernetes Administrator, and what you would do is you would come down here, and even if you weren't going to take this cert, even if you said, I don't want to take the cert, you could come here and you could go grab all of these for your notes. These are all the things that you need to study and know to be ready to maybe go, let's say, go get a job in Kubernetes. Let's say you don't want to get the cert, but you want to understand and be able to tell somebody that you can do Kubernetes. You could at least come here and say, here are the pieces. That looks kind of terrible, but the point is you could grab the pieces and go start studying and knocking them out, right? So I'm going to hit a lot of the individual pieces, but we're not going to dig into them like you would need to for the cert, okay? So that's my talk as far as that goes with certification paths. Look, there's a large overlap with CKAD and CKA, so I think you should study them together. I think there's a lot of value. All the certs are kind of expensive, but you get 2 free killer shell sessions, and you get a free retake. But also you can find the certs half off sometimes. So a couple $100 instead of $400. I think that's pretty reasonable. But even if you're not going to take the cert, you can still study the components and know the individual pieces, so that then you could put them on a resume, so that then you could look to getting into Kubernetes. And I think some of you guys have probably heard this before, but this is pretty accurate. The average salary of somebody with a CKA, last I checked, is $175 a year. 175K a year. And that's in dollars. And that's pretty decent. That's pretty good engineering money. That's middle of the road engineering money, right? So you can do that. All right. So then we come down here, how to deploy a 3-tier application. We're going to actually deploy this, right? Here's a diagram of our application. We're going to take so with a 3-tier app, you always have up front some type of web, or what people will call not appearance, but it's the it's I always think of it as the web tier or the front end tier, some people will call it. And then you've got your app tier. Some people will call this a back-end tier. And then you will have a data tier. Some people will call this a logic tier, and some people will call this a data or a storage tier, right? So you've got web or front-end, app or back-end, and then storage or data tier, right? As people like to call these. And there's different, you're going to run into different terms all over the industry, but generally that's what they are. Let's go look at like the way Google does it, because Google has a term for a bunch of this. Hold on. Let's see. Google. What is it? Let me go see if I can find it in AWS. This is how AWS says it, right? AWS says we've got a presentation, a logic, and a data tier. This is their architectural way of doing things. But it's all, I mean, it's all pretty similar. It all pretty much maps to the same general idea. Something front end doing load balancing, and then back end, which is your application or logic, and then where the data are stored, right? So here's our 3-tier app. We're going to build all our namespaces out. We're going to build out our storage and everything. We'll create deployments for each set of pods. We'll create an internal and external services so things can communicate. And then we'll test all of our application from end to end, okay? So let's do these things right here in the lab. So we pop over here, get rid of Ranger Cam for now, and I'm going to clear this screen up. And I am simply going to walk through the lab. This lab is part of a larger presentation given to Prolog and Redline Performance Solutions. So this is my presentation that was given for the Professional Linux Users Group. You guys are hearing it right now, so you're watching the presentation. I also give it to Redline, which is a company I work for. It is standalone, but far more context can be found from the Discord of the Prolog group. So you're getting all the context over here. Organization has tasked you with building a modern 3-tier application using Kubernetes. You have decided to use Nginx, Flask, and MySQL. You guys might say, he's insane, I would never use those 3. That's fine, change them out. I don't care which ones you want to use. This lab will work on these to build a basic proof of concept of the idea. Your organization would like a minimum level of security applied that follows best practice industry standards for Kubernetes pod deployments. Okay, we could do that. And it says, get started by setting up the namespaces, storage, and secrets you will need for your application. So we get our namespaces. They're really, let's go back to our normal node. Let's get our namespaces. There's none. There's not really anything special. Those are all the ones that are there. There's this ingress one that I created as I started the lab. So that's there. And we're going to create app 1 and data 1. So we've got our ingress Nginx as our presentation tier. And then we've got our logic and our backend data tier. Okay. We'll get our namespaces. There they are. And then we'll come down here and we're going to look at our secrets. We're going to make a secret. And the secret will be for a MySQL password called very secure. We're being very secure here, right? And we're creating that in an imperative way, which is, again, not the way we typically do those kind of things, but for the lab, we'll do it. And then we'll get the secrets and we'll see that there is a MySQL generic very secure command. Good. Well, let's go look at our MySQL storage. Our MySQL storage is going to be a persistent volume and a persistent volume claim. They're going to be 10 gigs each, and they're going to be set from the primary server here as mount data. So we'll go ahead and create that. So we'll create those two. And then if we go look at them, we'll see a persistent volume claim. So here's our persistent volume and our persistent volume claim right there. And we can run it again and we'll see them again. Boom. Okay. Then we come in and we're going to go look at everything in the ingress. So I'm going to move this over so you guys got a little more room. Here's everything in the ingress that we built beforehand. So I built this as we started the lab. Everything's up for our pods to be able to use the ingress controller. So that's good. We've got the front end presentation tier set up. And then I say, okay, let's go make sure, for one last little thing, let's make sure that Docker's there and we've got a registry running. I have a local registry running on this box. And the reason I did that is because I want to be able to push the pods that we're going to create up into that registry so that we can use them. Okay? So then we're going to look at our hosts. And in our hosts, we've got this application.lab.mine as our machine. And that's good. We need that because that's where everything's going to point to. All right. So we've got everything that we need for this part of the lab, so we're going to move forward. Now, we're ready to set up our application and data portions of the 3-tier app. So we're going to create a Flask application and expose it in an ingress controller. There's going to be a lot right here, but just suffice it to say that you could do this lab more than once if you wanted to. Then we're going to create a MySQL database and load it with some sample data, and then we'll test the ingress connection all the way to the app, and we'll make sure that we can get to the database. So, how does that look? Let's cd to our Flask Docker. And in here, if we go looking around in here, we've got a bunch of things that I set up for us. We've got a view.py, which is some Python. It's written in Flask. We've got a Docker file. So let's go look at these things real quick. The Docker file is going to pull Python 3.9-Alpine. That is an image out in the world. And then we're going to come down here and we're going to copy in some requirements, and we're going to install anything from the requirements.txt. We're going to look at those here in a second, but we're going to add that to the image. Then we're going to copy in our app, and our app is going to be this view.py. And when you enter into this container, you're going to execute the command from Python view.py. So let's go look at those real quick. The requirements that we add, really just Flask. We need Flask for this to work. All the other ones are just kind of defaults, but Flask is very important. And then if we go look at the Python, the Flask Python, it's super easy. It's the easiest one I could write, where we're going to simply run on port 6000 as our entry point. And when you enter into this Flask with a slash as just a primary, no additional pathing, you are going to be handed index.html. So what's index.html look like? It is simply, this is a Flask containerized app. It's just going to share all that stuff all the way through to the front of the page. All right. So let's build that image. So this right here is going to compose all these pieces up into an image called Flask Docker. So we're going to build that image. This will pull down the Python 3.9 Alpine. It'll pull in all those different components. And again, this is not a Docker, talk, but I think most of you can probably see Docker's doing some pretty simple stuff. We're pulling down that version. Don't worry about the little, I think I said here there'll be a little bit of red. Don't worry about it. Yeah. So it's done everything it needs to. We're going to tag and push it to the local repository. So it's going to go on localhost as Flask Docker. And then when that's all done and that's pushed to our local repository, now we control it. Now we're no longer pulling it from out in the world. We've got a local one. So this is what that Flask is going to look like when we apply a pod. We're going to just run a simple pod as test app 1, and we're going to pull it from the localhost 5000 Flask Docker container that we just built. Now, if you think through everything you know about it, that has Flask built into the image. Then inside that image, it also has a simple little app that is like the simplest little Python app ever that says feed the index.html to anybody looking. Here's the index.html, simplest little page ever, just says this is a Flask app containerized with Docker. We're starting real simple. We're just doing a static web page. And that's perfectly acceptable. You can run static web pages out of Kubernetes. There's no rule that says you can't. You would be like using a Lamborghini to like drive around potted plants, but you could do it. You know, you put them in the back of your Lamborghini to get them sun, and then you drive them around all day. That's fine. It's just not the most effective way to use that type of vehicle, you know. All right, so we're going to create that, and it says that the app was created. Then we're going to expose it with a service called app1, and then we're going to go look and see, well, okay, there's this one pod out there, and he is going to be running. He's up. He's good. We'll look at the service, and the service is pointing to that one app. So kind of like we did earlier, everything's pointing to everything. Then we're going to go look at this ingress tool, and the ingress tool is going to look for anything that you send is going to be rewritten to a slash, and it's going to go to application lab mine. The path will be test. So if you come in on /test, I will send you to test app service 1, which is this guy here, test app service. Yeah, test app service right here. Yeah, there's his name. And that'll point to this IP, which will point to this backend, which will go and open that Flask app, which will then show you that index.html page. And that'll be when you come into my server through, you're trying to go to application.lab.mine/test. All right. So now we're going to do the ingress part. So this takes, you know, again, we'll just create that. And then now if we go to curl application.lab.mine on the default external port that we see for it. I don't know. That's fine. And now we see the whole web page pass through. So all we did was go to the outside name and then port 3080 /test, and it passed all the way through, and it gave us that Flask app was there. It gave us the web page, right? So now, so we got that first part to work. This seems like a lot, but if we come over here, what we did was we have an ingress controller, we hit the Python backend, and then the Python backend just serves us a basic little page right here. Now we're going to build this database part, and then we're going to build a longer version that goes all the way through to that, okay? Clear as mud, right? I told you guys this one was a little longer, a little more challenging, right? So let's go look at the MySQL deploy. And the MySQL deploy is going to be a deployment. Look, there's a service as well. And then there's a deployment. And the deployment is going to go to data, MySQL. We're only going to have one container. And it's going to be MySQL 5.6. And it's going to pull in the root password that we gave earlier. Very secure, right? It's going to use container port 3306, which is the default for MySQL. And it's going to go mount that persistent volume claim. So even if we destroy this pod, if we recreate this pod, it'll be the same backend data store. So our database will still be secure. Okay? Or not secure, but it'll be backended to an actual location as opposed to an ephemeral storage that gets blown away. All right, so we're going to create it. That's good. We were happy. We'll go look at the service. We'll see that it's not pointed to anything yet because the pod's not up. So we'll give it a little bit of time. It says you might wait about 15 seconds or so. So we'll sit here. And then when that's done, we'll go look at the deployments. We'll see that it's up. We'll see that it's running. If we go back and look here, now we'll see the service properly backending to that pod on the right port. Everything's working. Come down here. And what we should be able to do then is we can load our database with some sample data. So I'm going to run right here. We're going to deploy a pod locally and use it to connect to the database. So this is just a MySQL client that's using MySQL 5.7, which is a slightly newer version. That's okay. And we're going to drop into this container image right now just for the 1 second that we need to load the data. So now I'm down in this shell image of this Docker container that I'm running. It's a full pod, but we're just running it for right now. And in there, I'm going to say, can I get to my data? And yeah, I connected to the database. So I'm connected to that database back there. And I'm just going to do this whole big long thing here. I'm going to create a database visitors. I'm going to use visitors, and then I'm going to load it with a schema. Whoops. I'm going to load it with a schema that I want to use. And then I'm going to hit enter, and I'm going to load it with 2 pieces of data. So here we go. This isn't a database class, but we can create a database visitors. We can use visitors. We can create a table with a person as an integer, person ID as an integer rather. First name is some variable characters and last name is some variable characters. There is a user named Philip Devnall. He's user 1. And then user 2 is Het Tanis, right? And those would be 2 pieces of data in there. And then if I want to exit the client, I can type exit. And then from right here, I should be able to just run MySQL and see that there are those tables. There's tables and visitors called persons, and then here's their information. All right. Now we type in exit, and we leave that pod. That pod is gone forever, and it gets deleted. So, real quick. I know there's a lot going on here, but what we just did was we built this database. Then we built a little pod down here that wasn't even in here. We just built a pod off to the side and loaded data into our database. There's no security here, so everything can talk to everything. But shortly, we're going to lock it down so that doesn't work anymore. But we loaded some data into our database, and now it's sitting on the persistent storage. We could blow that database away and restart it, and it would still get that same data storage. It's still there. So we come back over here real quick. Boom. And now we're going to do a read application. So we're going to do another Flask read Docker. And if you look in here, you'll see that this is a read Python. And let's go look at how this one's going to work, right? It's going to be the simplest things ever. Requirement is going to be Flask again, but now we need PyMySQL because we're going to be reading from MySQL, right? So that's our requirements. That's going to get built in to the Docker file. So here's the Docker file. Pulling down Alpine, doing the same install of this new requirements directory or new file with the PyMySQL. And then we're going to pull in Python and read.py. So we're going to run read.py now. So let's go look at what that looks like. This is also a very simple Flask container. There are 3 things that I did here that you normally don't do. You would normally not give the host string right here. This is a security violation. You would 100% never in a billion years give this, but I did it to show that it could be there. We could feed this in as a variable from from Kubernetes. We could store these as a secret, but I left these here to show you that they exist, and then I can call them out. And I want you to see that we could variabilize these just like we variabilize the code of the secret password earlier by putting in a thing. Hey, Luis Codes, how's it going? Hopefully this stuff's useful to you. So again, you know, I'm not a coder. I don't do this stuff professionally, but I can at least do this. And then now when you come into this one, which again is called read, you're going to go and we're going to go query from that database that we have up here. And we're going to pull down everybody out of persons. And then we're going to render him in this new index.html. Well, Cutolingus, because, well, there's a couple reasons we don't do this. One, it's not super secure to put stuff like that where you're connecting. Like our database strings, we tend to consider them kind of private. And 2, the reason I really should variabilize this and this and this is another reason, is that this right here is now what we call bespoke. Does everybody know what the word bespoke means? Bespoke means, some people might say I'm beholden to, but bespoke means this is only created for this one environment and it will only work in this one environment, and it is absolutely effing useless everywhere else on planet Earth. That's what that means. This is bespoke now. But hold on, if I variabilize this and this and this, and you go take it and you go put it in any other environment on planet Earth where you feed in host and user and password, now this is useful anywhere on planet Earth. Does that make sense? Any Kubernetes cluster could run this, provided you have the right index.html and other things. And this string would be, so what if instead of this, because this might be my production string, but I want to deploy 100 of these down in test. Well, the test environment, we should be able to code in a environment file and just give all of these values. This actually comes from 12-factor, and I know people hate hearing this, but 12-factor app is a set of things that you should do if you want to be a DevOps engineer. I'm not a DevOps engineer, but I'm going to tell you, they very explicitly say this right here. Codebase explicit configs, store configs in the environment, and feed configs in through a variable like thing. So you can go read about all these things, but this would, if I put those variables in, we would have this, because then everything would be similar. You would just deploy to each one, and all you would have to do is feed in a different environment variable. Now, I tell you guys all the time, I'm a Linux engineer, I'm a low-level guy, but I also do Kubernetes to support it, so I understand how to do this stuff, right? Like, I wrote all this, but I don't do this professionally. This isn't what I do most of the time. I just support the guys that do. So we looked at our read.python. Now let's go look at our web page. Our web page is super simple. It's a basic little index, but now it's going to read in the results from the database. So it's going to say for row in results. Results were gathered up here, right? And it's going to now print out for anybody that reads the user, his first name and his last name. So it should be ID1 Philip Devnall, ID2 Het Tanis. That's what should be generated right here, right? So we're going to build all these pieces together. So Docker, if you've never built a little Docker container image with a Docker file, all it is it's going to take all of these components here that we just looked at and stuff them all together into a Docker image that was built off of the base Python 3.9, right? So this thing's all done building. Don't worry about the little errors. You shouldn't use pip, whatever. And now we're going to push that up and tag it as Flask read Docker on our local system. And then we're going to go look at, we're just going to create it in Kubernetes. We didn't even look at it. If I wanted to look at it, we could do that. It's super simple. It's going to pull down that one just like we did on the other one. And then now we can go look at it, and we can see that read app and test app are both there. And then we've got a service for, oh, I didn't make the service for the read app. Let's expose it, and then we'll go look at the service, and the service is pointing to the right backend, 05. 05 is the read app. Good. Everything's pointing to everything. So now we're going to go look at our new version of this ingress. So application lab mine, if you go to test, you're going to get to the test app service. If you go to read, you're going to go to the read app service. That will point you to the pod. The pod will go and read all the data out of the database, and it'll serve you an HTML back, which is a readout of what's in the database. That's all we're doing here, right? So we did that. Let's delete the old one and create the new one just for fun. And then we'll go look at both of the applications right here. So first one is still just a read, test of everything. And the second one is the read with, this is a read of the database. One is Philip Devnall, and 2 is Het Tanis. Those were the 2 values that we stuffed into our database, right? So we hit check, lab's happy, and it says now the application needs security. So we have built all of these pieces, and we have tested the test goes to here and verifies this part. Read hits here and goes all the way back to the database and comes all the way back forward and gives us everything. So test, like if I were to draw this out real quick, /test is going to here and back, right? Boom. And read, it's not really a capital, but read is coming all the way back here, generating a web page for us from the stuff that it read, and come back out here. All right, but now we want to secure this a little bit. We're going to make our code better. We're going to do better things, but this is what we've done so far. The next part is securing it. So now to secure it, we're going to take that read application, we're going to make it immutable, meaning nobody can change the base code. Even if you get into the pod, you can't write anything to the actual any storage. And then we'll have no root applied, so even if you get in, you can't escalate off of the user that you are. And then over here, we're going to write a network policy. Network policies really get people inside of Kubernetes. And the network policy that we're going to apply to data 1 namespace is that the only people that can come into this on port 3306 are going to be in the app1 namespace. So you're going to have to be in the app1 namespace in one of these read pods to be able to read it. And we'll test from out here, and we won't be able to read from our database anymore once we apply it. All right. So here's the things we're going to do. Test, 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 test. Right? Those are all the things I said we're going to do. So, if you're following along, now the application needs security. Create network policies, make the app and read pods read only. So, here's the network policy. Here's 2 network policies, and let's look at them. The first network policy denies any ingress into this system, any ingress into data 1. And then the second one punches a hole and allows port 3306 to come in only if you come from the namespace app1. So, some of you are used to like networking, and in networking we have access control lists, and when you fail out of an access control list, you never get to go through again. And some of you come from AWS space where we have identity and access management policies, and in those identity and access management policies, if I ever deny you, you will never, ever, ever be allowed through again. Well, that is not, neither of those models is the way Kubernetes does it. Kubernetes does it in an additive way. So this right here is like I put a veil across everything. There's no way to get into this via ingress anymore. You can't get in. Nobody can get in. Once I do this, nobody will be able to get into that namespace. But then this one will punch a hole in that. It's an aggregation. It's not a, in network policies, we say, well, I've denied you, so now you're out and you no longer get evaluated anymore. But in Kubernetes, it overlays all of them at the same time and says, there's a deny of everybody, but we've got this hole right here. Data 1 can be accessed on port 3306 if you come from the namespace app1. Does that make sense? So it's an additive. It's like everything's overlaid and taken into account at the same time. So it says that here. We're going to create the network policy. We're going to create the network policy. And then now let's make sure that all communication can still happen. Yeah, because guess what? This communication is here. And it's going in. That should still work. We didn't break that. But now that that network policy is applied here, this read can only still happen because you're coming from the back end application in here and going to connect. And it's specifically the read one, right? So that's really important that you kind of understand that. All right. So anyways, here, all the functionality is still there. And then we're going to go change it and we're going to verify. Look at this. This is some default MySQL client out. This will be run in the default, what's it called? The default namespace, because I didn't give him an explicit namespace. And he's going to try to connect and see if he can talk. And he is not able to talk. Look, nothing's coming back. And that makes sense because logically, he's out here. He doesn't have a right to go in there. So now we're going to destroy him. So we're going to destroy this guy out here. Look, we're out here. And we're trying to get in. And we're getting a big X. So now we're going to move him up here by putting him in the namespace. And this should go through with a big check mark. Okay? So let's do that. Because that's the next part of the lab right here. We go here. That's just hanging. That's going to hang forever. So I'm going to exit this. And I'm going to do the same thing. But now he's in the napp1. So he's going to be in the right namespace. Whoops. Let's get out of there. Hold on. Exit. I'm in the wrong space. Get all the way out. Okay. Now we're going to go into there. And we're going to build him in app1 now. So now he's in the right place. And we'll do that same command again. And he immediately can read. because now the network policy is not blocking him anymore. Does that make sense? Very important concept to understand, and you've got to spend some time with it. But visually, this is what happened. This guy breaks because he doesn't have permission to read in there. We did the exact same command, but in the namespace app1, and he got in immediately. That's all we're doing right here. That's literally all this is. Here, you do not see him being put in namespace app1. And here, you do see him be put in namespace app1. And now he's got the permissions. So, we're going to delete the pod read app1. We're just going to get rid of... Oh, well, we got to get out of there again. We're going to delete the read app1. And we're going to verify with the secure app1. So now, look at the secure app1. He has security context run as user 1000, which is the user Ubuntu. And then over here, the security context is we're not going to allow privilege escalation. And we're going to make the root file system read only. So now you can't change it. And then we're going to recreate this pod right in place. We literally just went right here and destroyed read and put it right back in place, but now as a secure version. And then what do we want to do after that? Well, we want to test that we can still read. So now we can read. We can get all the way through to the back end. Remember, that's not cached anywhere, guys. That's being generated in real time. Every time you do this request, that's going all the way back to the database every time. But there's this one is not being blocked. It's this. Read is not being blocked, even though we redeployed the pod that the service read is going to, right? All right. I know it's a lot. So here's our review. We did some Kubernetes basics. We talked about certifications. We deployed a 3-tier app, and we did a whole bunch of pieces with it. Nginx, Python, Flask, MySQL. Then we secured it as best we could and made sure it was pretty solid. We did networking to make sure that the network policy only allowed things to come in that should. And then we kept going. So real quick, I want to show you guys. I could have, and I meant to do this in this lab originally, but I didn't. See how we only allow 3306 in from here? I could have locked down right here, and only people coming from the ingress front end would be able to get to that back end pod anymore. And then, so whereas like here, currently, oh, wait, not that one, that's my home stuff. Here, we could go directly to it. We're going through the front end here. We should have been able to also, if I did Control R and then read, right? And then Control Shift R to go back. Whoops. Oh, I blew my whole lab away. Jeez. See, that's the problem, guys. When you do cool little command line stuff that you try to do inside of a web browser, it's not going to work right. All right. Anyways, we could have. That was my own fault. Yeah, I didn't mean to. Control Shift R just reloaded my tab, so I lost my web page. Don't do that. Gosh. All right. Anyways, you get to do the lab again if you just followed my thing. But I was going to apply a network policy to the app and then not let you get in unless you came in through the front end. So I could lock the app down as well, right? Maybe for denial of service reasons. I don't want people hitting my apps that I'm testing and slowing down my speed tests or whatever. All right. Cottywomple. So this is where do you go from here? So you've seen a 3-tier app deployed. Maybe that's interesting to you. Maybe you're like, I want to go be a software engineer and build stuff on top of that. That's what a lot of people do with their career. Maybe you want to do kernel security. So you want to learn about eBPF.io or Falco. Or you want to learn about sandboxing. So there's a lot of other ways to secure that cluster we were just looking at. There's a bunch of networking stuff. If you're struggling with the network policy, there's a really good network editor. Let's see what this looks like. This is a Cilium editor. I think you have to sign in now on this. I don't think you're allowed to do this for free anymore like you used to. But it's a policy editor, and you can go and you can build things. I don't think you're allowed to like edit these directly anymore. I don't know how to change this. I think they made this not as free anymore. You got to sign in or something. So I don't know how to change that. But the point is, you can visualize the different things that you see here. All right. Then there's a bunch of monitoring stuff you can do. Prometheus and FluentD can pull things out of your Kubernetes clusters and keep track of all kinds of things. There's free hands-on labs on Killercoda where you can go spend all the time in the world on this and get good at it, right? All kinds of ways to learn and spend time in here. And then more questions, my contact info. You guys know how to get a hold of me. Just go on Discord, right? So Discord's the best way to get a hold of me typically. So remember, guys, this is what we do, right? We come in, we figure out how to deploy something, we figure out how to walk through it, and then we figure out kind of how it works. All right. Oh, that was from yesterday. All right, so here's what I'm going to do, guys. I'm going to go find somebody to raid. We'll end a little bit early today. We did about 2.5 hours. We'll get back to it this next week, but we're getting ready for all the stuff coming down. We've got a whole bunch of lab stuff coming up in the next few weeks and a whole bunch of work for people that want to get better at systems administration. I can't promise you guys that this will be easier. I can't promise you that this stuff will even get easier. You just have to keep working at it. Oh, the access to the slideshows here. If you go on our Discord, which is just Discord, that's under presentations. I got a whole bunch of presentations up here, but that one is called the 3-tier app, and I think it's right. Here's CKA if you guys want to get ready for your CKA. 3-tier apps right here. Kubernetes presentation on 3-tier apps. So there you go. And it's got the links and the drawings and stuff in it. So you guys are welcome to hang out. And I tell you guys all the time, you can hop into our Discord. You can take everything like a cartoon villain and then you can leave and I wouldn't care. Like my only goal here is to get you guys doing this stuff. And if that helps you, I know you're not probably going to do that. But any of you guys that want to get into this and do that kind of stuff, you're welcome to take it and go look at it and then show back up in the server later, you know? It's up to you guys. So, okay. All right, let's go find somebody to raid on the Twitch side, and then on the YouTube side, unfortunately, I got nothing cool like that for you. But I will see you guys over on the YouTube side later. Let's see who I'm following over here. Who's doing stuff? Rob is on. What's Rob doing? Rob's doing some stuff. These guys are all doing stuff. Let's go hit up Rob. Whoops. Yeah, let's go hit up Rob. All right, I will see you guys. Oh, well, I think he's programming over here. We'll go hit him anyways. So, all right, take care, guys.